Next, we'll welcome Dr. Sareena Karapoola, who works in the area of malware analysis, detection engineering, cyber threat intelligence-based research, and Gen AI-based automation at NEC. NEC has published 53 recommendations into the MITRE ATT&CK Framework from versions 9 through 16. Thank you for your contributions. Instrumental to this has been their application of TRAM, which we learned about earlier, and their customizations to TRAM for their own operational needs. Let's hear about it.
So thank you for your introduction. So we are very honored to be here today. So our title of our presentation is Accelerating Identification of Attack Techniques in Threat Report. Okay, this is agenda. So after a brief introduction, I will show how we are achieving intelligence activity at NEC Corporation. So after that, I show the result of our analysis. It shows a 4.5 years trend in top 10 MITRE ATT&CK techniques. So after that, Dr. Sareena will explain how to improve the efficiency of attack mapping. So, okay. So I'm Takahiro Kakumaru. I'm worked for NEC over 24 years. So mainly in the area of cybersecurity and also research and development area. So currently I'm leading a cyber intelligence group in NEC Japan.
Hello. Hello everyone. I'm Sareena from India. So I work along with Kakumaru-san. So I have been in the industry for close to 20 years. And in between that, I plunged into academics for research in cybersecurity, completed my master's and PhD and came back to the industry. So I work now in the area of malware analysis, Gen AI-based automation, AI for detection, in these areas. It's my pleasure to be here and to interact with all of you.
So at NEC Corporation, we have about 10 members for cyber intelligence team. So our role of our team is to support CISO with strategic intelligence and to support product support team and incident response team with tactical or operational intelligence. So we have been working together with several branch office in NEC. So in particular, regarding MITRE ATT&CK related activities, we are working together with NEC Corporation India security team. So mainly their mission are MITRE ATT&CK related work, for example, MITRE ATT&CK analysis, customized TRAM and malware analysis, and so on. So the result of our activity are not only used by ourselves, but also we continue to we are working to contribute this result to external party, external community. So as one of the results show right-hand side, so we to identify some novel techniques during our analysis. So we continue to propose our recommendation or proposal to MITRE. So thanks to MITRE's help, so so far totally 53 published by so far. So I very thank you for MITRE's guidance. And also we continue to contribute this result to other community globally. So I will show the result of analysis and data collection over 4.5 years. So we had started at 2024. So this graph shows the result of MITRE ATT&CK analysis. So we have been analyzing in total more than 1,246 reports so far. So this shows the average number of reports analyzed per half year is 138 reports. It's more than one report per day. So please look at detail in later, but if you can see this graph, so top 3 ranked could be not so different for long time. So these three are command and script interpreter, English to transfer, and obfuscated file or information. So if I had to pick one point from here, it would be system information discovery here. It's represented as an orange line. So I'm feeling that based on the research analysis work, recently, as you know, ransomware technique has been changed quite a lot. So I think ransomware group just not try to encrypt data soon, but they try to hide system once. So and look for some important asset or data to be encrypted, which would be a big impact. So this shows some reflect with the current situation I'm feeling. So then next, Dr. Sareena will explain how we can improve our mapping efficiency, please.
Thank you, Kakumaru-san. Hello, everyone. So here we are going to go into detail of how we can improve, how we have tried to improve the threat report attack mapping efficiency. So integral into our journey of this last 4.5 years, where we have been analyzing threat reports and gleaning cyber threat intelligence, is MITRE Threat Report ATT&CK Mapper. Thank you to MITRE, because we have been using it rigorously in a daily manner in order to glean these cyber threat intelligence. Now, and over the years, we have customized it to map to our operations, to map to our activities, and improvised it. Now, in the interest of the audience, just to give a background of what TRAM does, Threat Report ATT&CK Mapper does, is the box above. So you have threat reports that are coming about emerging malware. TRAM ingests this, and analyst uploads this report into TRAM, Threat Report ATT&CK Mapper. That has machine learning models. This open source TRAM has some models around logic, LR, logistic regression, SciBERT, etc. So these models generate attack labels for each of these sentences. So the threat report is tokenized, grouped into sentences, then mapped with the attack labels, and that labels are validated by analysts, and then this forms the MITRE attack techniques. Now, into this workflow, we have done a couple of customizations. The first one is like the technique prediction. Technique prediction, we have tried to increase the coverage of techniques from what is there in the open source, which is around 50 techniques that it supports, because as we were using TRAM, we found that it has been incapable of detecting a wider range of techniques reported in MITRE. So that's one area we have worked on, and also improving the accuracy. In addition to this, to improvise into our workflow, because we believe sharing of cyber threat intelligence is the key thing to this community. So we have automated this process of analysis and standardization for sharing of intelligence. So we have like the workflow formulates this MITRE recommendation from these threat reports for submission to MITRE. That's where like we regularly submit to MITRE. So we also extract the IOCs, attack patterns, and also standardize that for sharing with cyber threat intelligence platforms. So this is what you see below is what we have customized and is what we have been using since a couple of years, which we call NTRAM going forward. Right? Now we'll just get into a little the challenges that we encountered when we were trying to improve the efficiency. First one is coverage, as I mentioned. OpenTRAM was supporting around 50 techniques, and with a pretty good accuracy, 81% of F1 score for those 50 techniques. But MITRE attack, I mean, the latest one on 2024 has around 537 techniques which have been reported. So now how do we enhance TRAM to support these 537 techniques? So that's the first challenge. Second is skewed representation. We have around, among these 537 techniques, more than 300 techniques have less than 10 representation. So now when you feed this into the model, that's where the skewed representation, the algorithms were performing low on skewed data. So the models within TRAM, which were trained on 50 techniques, we tried training it with a larger number of techniques. So that's where the challenge we felt. So the way forward, which we envisaged, is how do we enrich the data? Now, how do we get more precise data with a higher representation for each technique? Now, MITRE ATT&CK is the Bible, so it has the ground truth or a Bible of techniques. So, but how do we find alternate data sources for data to augment this MITRE ATT&CK for the models to pick up the technique prediction accurately? And third thing we try is, can the data sources, what we have, what we try to find out, can be combined to ensure that each technique have sufficient representation? And the second dimension that we look at is algorithms. Like, how do we enhance algorithms to perform better on skewed data? So these are the two dimensions that we took in our journey, and we'll go into each of them. So data sources. Now, what is the optimal data source for training your model for MITRE ATT&CK prediction? Now, the first one is the ATT&CK 2024. As I say, it's the Bible of MITRE ATT&CK techniques, because it is the ground truth, precise sentences from MITRE about each technique, right? Now, the only challenge there we face is it's kind of skewed. It does not have a representation for, like, majority of techniques which are very newer, novel techniques have very few examples there. Second thing that we tried was the historical data. We have been using TRAM and TRAM over the past 4.5 years. And each week we analyze around 10 threat reports. It's like an approximate number where we map each sentences to attack technique. So those sentences is a historical data that we have in our database. So that is like kind of where like sentences mapped to a technique, the output of the TRAM tool was also stored as a historical data. What we found is it's kind of very verbose, because, for example, MITRE ATT&CK database is kind of very precise, for example, command shell interpreter, whereas historical data will have like a lot of story around it, and then you have the key words there. So that's the data we had. Third set of data is the TRAM analyst comments. So in our weekly analysis, whatever threat reports are mapped to techniques, there is an analyst validation that is happening. So where they write, okay, this is being, they put their comment to validate it. So we have been accumulating this analyst comments also, which we find is kind of a vetted data of this historical data. So it's like something which has been validated by an analyst that this mapping is right. So this is also a third source of data. And so then we tried our experiments with combination of data sources and models for a different range of techniques. So in the table to the left, the other side, you have like first 4 rows are with where the model is trained on the 50 techniques were similar to TRAM. And we have like the data set used for training has been increased, like incrementally. We start with the attack data set, then we add in historical data, we add analyst comments. We also try with just analyst comments. So what we see is, as we increase historical data and analyst comments, we are able to see an improvement in performance of prediction of techniques. Okay, so that's one particular observation. Second, we try to increase now the number of techniques that the model is trained on. So we increase it to 236. From the 537, we chose 236 for a more kind of, which have a kind of some decent representation of more than 20 examples. Now, what we see here is that on data with larger number of techniques, we see that SciBERT, which is failing miserably, and the performance is a bit dismal, but GPT-2 is being able to perform better. So that's where we take that and deep dive into it to see how we can improvise there. And another thing, what we find, like as the data is skewed, again, GPT-2 is also facing that challenge, and there we need some optimization to handle the skewed data. So this is what we try to do in our next slide on prediction, the model as such. Now, how do we handle skewed data is what we try to cover in this particular slide. So if you see to the left, to this corner, you have the representation of the data of this 537 techniques in attack. So if you see, it's like highly skewed, like more than 99 have only one representation. So what we do is kind of divide the technique space among specialized models. So we divide and conquer strategy kind of thing. We divide it based on, you see, like greater than 300 representation for a submodel 1, which is specialized in that. You have submodel 2, which is specialized on another set of technique space. Likewise, 3 and 4. And this is something which can be designed based on how you want to divide it. Now, one challenge that we face here is you have multiple experts to solve the same problem. The sentence goes to all the experts, right? Each expert have their own opinion. And one of them would be right, others would be conflicting. So how do we come up with a consensus model to know, okay, this is the one, submodel 1 was a person who has to predict on this, and that would be the right. So that we have a consensus module there for selecting the correct prediction. So right now we use threshold to identify the correct one. We can input more insights into it to have a better prediction. Right. So the results so far, so these are interim results we have. What we see is when it's trained with 283 techniques, we get around 0.86 of F1 score, which can be improvised further. Now, to conclude, what we have observed is using of historical data along with that analyst reviewed comments, so that validated data is helpful in increasing performance. And also, when it comes to models, we need to come up with some strategy to address skewed data. Now, what we tried here was based on the number of examples that are available, but what could also be a better optimal division of technique space would be based on maybe the similarity of techniques, similarity of tactics is something which we are currently exploring. So this is something, a future optimization to this work. And this is something which we are planning to have it as a research publication as well. Okay, finally, there is a big team behind this at NAC Corporation as well as NAC Corporation India, and we would like to thank each one of them and acknowledge their contribution here. Thank you.